Hi there, and welcome to today's video where we are going to be looking at scientific notation, and we're going to be looking at two different concepts for scientific notation. First of all, we're going to be looking at how to transfer a very large number into scientific notation, and then we're going to be looking at how to properly add for scientific notation. So before we get started, make sure that you like and subscribe to the channel so that way we are knowing whether or not these videos are working for you. And let's get started. So first of all, what is scientific notation? Well, scientific notation is a way that we are able to take really, really large numbers and make them more efficient, which means that we're writing less, because math is all about finding efficiencies. We want to find easier ways to do things, and our brain likes using smaller numbers. So we've got a number here, 365 million. It's a big number. We've got a lot of digits there that we're looking at. And what we can do is we can find a way to make this smaller. And we do so by doing something called scientific notation. Now, it might be a brand new concept to you because scientific notation is not really taught until we get into middle grade or intermediate grades levels. You guys are probably familiar with taking expanded form, which means that you would be looking at 300 million plus 60 million plus 5 million, and then taking those and adding them together. Well, in this case, what we're doing is we are taking this number and we are making it into something smaller that we can use. This is how it works. Let's assume that there is a decimal right here. And what we're going to do is we're going to move this decimal place a number of jumps. And every time that we are going to be making these jumps, we're moving in the place value column by tens. Okay, so the goal here is to get our number to fall somewhere between 1 and 10. So if I move it here, we've got 365 or 36.5 million. That's still not between 1 and 10. If I move it here, same thing. What I want to do is I want to move the decimal all the way to here, because if I move the decimal to here, now I've got 3.65 and it fits my in between 1 and 10 criteria. And now what I want to do was every time I moved the decimal, I was moving by a group of 10, like place value. So what I want to do is put down multiplied by 10 and then an exponent. And the exponent is determined by looking at the number of jumps that I've done. So I would go 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump, 7 jumps, 8 jumps to end up there. So scientific notation of this number would be 3.65 times 10 to the number of jumps, to the power of 8 in this case. And if I broke this number backwards, back down, what I would do is this. I would take, and we'll switch to blue for this. Blue. What I would be doing here, if I was working backwards to see what the number actually was, I would start with 3.65, and then I would put down a certain number of zeros based on the number that I have right here. I look here and see that there are already 2 jumps that are going to take place. 1 jump there, and then a second jump to get behind the 5. And it's important to note that when you do your jump, it is not the number. It's the decimal before or after the number. So make sure that you're aiming for those spaces in between to make sure that you get it right, because it's very common that kids will end up on a number and then just kind of guess on which side the decimal goes to. So make sure you're ending up in between your values, your digits, in order to get this correct. So you can see that there are 2 jumps that are already happening right here to get the decimal back behind the 5. I need to have 8 total jumps, so the difference between 8 and 2 is 6. So I need to have 6 more jumps happen. So if I put down 6 more zeros, I should have the number of jumps. I've got 2 jumps to here. This would be jump number 3, 4, 5, 6, 7, 8, and the decimal goes behind. So I had 2 jumps and then these 6 jumps for a total of 8 jumps, which was that number right there. And you can see that I've expanded that number to now have its standard form. Instead of it being 3.65 times 10 to the power of 8, it is now 3.65 or 365 million when I look at the expanded form. So that is moving from a large number to scientific notation, moving from a large number or from scientific notation back into its expanded form. Just working forward and backward. Now let's look at this. I'll start by telling you that the rules apply for addition and subtraction when we're dealing with scientific notation. Okay, so the first rule that we want to look at is we want to make sure that our exponents are the same. If the exponents are the same, it makes things way easier. We're just simply going to take the base numbers, like 1.25, and add it to 3.1, and then keep these the same. So it would be 1.25 times 3.1, or plus 3.1, which would be 4.35 times 10 to the power of 3. Okay, they would not change if they were the same. But in this case, we don't have that luxury. And what we've got here is we've got 1.25 times 10 to the power of 2. So let's think about that for a second, because this will matter. 1.5 times 10 to the power of 2 is the same as 1.25 times 100, because 10 times 10 is 100. Which means 2 decimal places over, which means I'm looking at this number value, this value right here is 125. And then if I look at this one, I've got 3.1 times 10 to the power of 3. Well, 10 times 10 is 100. 100 times 10 is 1,000. So I would be taking this and multiplying it by 1,000, which would be 3,100. So this number right here is 3,100. This number right here is 125. Okay, now let's keep that in mind as we go through this, because there's very common mistakes that are made. I'm just going to erase this because we're not going to need it right now. Okay, so what I have to do is I have to find a way to move this decimal up or move this exponent down. Okay, so one exponent has to either be 3 or I have to switch the 3 to a 2. Either way works. And we'll do both ways so you can see how it works out. So let's start with this. Let's start by making this a 3. And what it means is, if you remember what we did over here, we were moving the decimal, and as we were moving the decimal to the left, we were increasing the exponent. So this was going up by 1, up by another 1, by another 1, by another 1, until we ended up by moving that decimal a total of 8 places, or 8 groups of 10. So we're going to do the same thing here. We're going to move this decimal there instead. And in doing so, what it's going to do is increase this exponent to a 3. So we have 1.25 times 10 to the power of 2, but if we move that here, we're technically decimal 125 times 10 to the 3. Okay, now I want to see, let's check this to see if it's correct. We knew that this number was 125 in total. Okay, 125 in total, which means that if on my calculator, if I took decimal 125 and times it by 10, by 10, by 10, I am going to end up with 125, which was the original number. That's important because oftentimes kids might subtract this and it's going to change the number, what the original number was. So keep that in mind as we work through this. Let me grab my eraser here. So now what I've done here is I have decimal 125 times 10 to the power of 3 plus 3.1 times 10 to the power of 3, and now I can solve. I'm simply going to take decimal 125 and add it to this for a total of 3.225 times 10 to the power of 3. Okay, decimal 125. If I remember just place value here, this would be decimal 125, 225, and that gave me this answer. Now let's go the opposite way. Let's change this to a 2. Okay, so let's change the color as well. Let's go green. It's been a while since I've used a green marker, I think. Make sure that it actually has got some ink to it. Perfect. Okay, so we are going to keep 1.25 times 10 to the power of 2, and to it we are going to add 3.1 times 10 to the power of 3. Now what we're going to do is we are going to move the decimal the opposite way. we're going to move it to the right. And if we move it to the right, we can't add. Making the exponent larger doesn't make sense. It's going to end up with a different number that's larger than what our original number was. So we are going to move this decimal by a group of 10 to the right, and as a result, this is going to go down. It's going to be subtracted, and it can subtract into the negatives. So technically what we have is 1.25 times 10 to the power of 2 plus 31 times 10 to the power of 2. I want these two exponents to be the same. And let's think about this for a second. Oh, that'd be 100, sorry. 31 times 10 to the power of 2 would give me 31 times 100. If I think about that, 31 hundreds is 3100, which was that number right there that we started with. And now that I have this, here's how we can make this work. I just simply add across and keep the exponents the same. So I've got 31 plus 1.25, which is 32.25 times 10 to the power of 2. And you'll see here, this number is the same as that, but these exponents have changed. If I were to break those down into a standard form, the answers would be identical. 3.225 times 10 to the power of 3 would be moving that decimal place over 3 spaces, 3 jumps. 1, 2, 3. Over here, I'd be moving it 2 jumps. 1, 2. And you can see that the number is 3,225. Now that is going to work for both addition and subtraction. So let's recap what we've done here. We have taken a very, very large number and we've changed it into something that's much more friendly. We have taken it and put it into scientific notation simply by counting the number of decimal places over we are moving and adding times 10 to the power of the number of jumps. If we have scientific notation, we are keeping in mind the amount of jumps that we have to make and adding zeros as placeholders. So in this case, 3.65 had 8 jumps. We jumped twice to get behind the 5. And then we added 6 zeros to make up that extra 6 jumps that we needed to give us our 8 jumps, and we found out that we had the exact same number. When we're looking at addition or subtraction of scientific notation, what we need to remember is we need to get the exponents the same. And it's going to simply be moving the decimal to the left to add or increase the exponential notation, or moving it to the right to move it down, where we will be decreasing the exponential notation. Both of the answers, as we work through, are the same. They are equivalent, as we call in math. 3.225 times 10 to the power of 3 is the same as 32.25 times 10 to the power of 2. 3.225 times 1,000 gave us 3225. 32.25 times 100 gave us 3225. The numbers were the same. All right, that is scientific notation, looking at how to break it down, looking at addition and subtraction of it. If you have any comments, by all means, please leave them down below. Don't forget to like and subscribe to the video, and we will catch you next time on our next video. Thanks very much for watching. Good luck.